Hi guys, today we are going to start a completely new topic which you haven't heard of till now. It is coordinate geometry. I promise you that once you get to know what exactly is coordinate geometry and how it works, this will become one of your favorite chapters. So let's start. You have already studied how to plot a point on the number line, right? Mathematically, each number on the number line is called a point. You also know how to describe the position of a point on the number line. Like consider the number 2. It is right here on the number line, right? But there are many other situations in which to find a point, we are required to describe its position with reference to more than one line. To understand better, consider these situations. Suppose you just arrived in a new city to meet your friend. Now, to reach her, you must locate her house, right? Well, she has already given a map of her area and told you that her house is located on the second street. So, when you look at the map, you see there is a main road running in the north-south direction and streets with numbers from north to south. Also, on each street, house numbers are marked. Now, to look for her house here, is it enough to know only one reference point? For instance, you only know that she lives on street 2. So, will you be able to find her house easily? Absolutely not, because there are many houses on street 2. You can't go knocking on each door to locate her. This means to know the exact location of her house, you must know two pieces of information about it, namely the street number and the house number as well. So, you called her and asked for her house number, and it turned out to be house number 5. Now to reach the house which is situated in the second street and has the number 5, first of all, you will have to walk to the second street and then towards the house number 5 on it. Congrats, you reached her. I wish you a pleasant stay. Now let's see one more situation. Suppose you put a dot on a sheet of paper. So if I ask you to tell me the position of the dot on the paper, how will you do this? Perhaps you will say that the dot is in the upper half of the sheet. But there can be many dots in the upper half. Or you will say that it is near to the left edge of the sheet. See, there can be many points near the left edge. Or you will say that it is very near the left hand upper corner of the sheet. But do any of these statements precisely fix the position of the dot? No. But if you say the dot is nearly 5 centimeters away from the left edge of the paper, it helps to give some idea but still does not fix the position of the dot, because still there can be many dots just 5 centimeters away from the left edge of the paper. But if you mention that the dot is also at a distance of 9 centimeters above the bottom edge, we will know where the dot exactly is. So, to exactly locate the dot, we fixed its position by specifying its distance from two fixed lines, the left edge of the paper and the bottom edge of the paper. In other words, we need two independent information for finding the position of the dot. Great. So we saw that the position of any object lying in a plane can be represented with the help of two perpendicular lines. A plane is basically a flat two-dimensional surface that extends infinitely far. This simple idea has far-reaching consequences and has given rise to a very important branch of mathematics known as coordinate geometry. So, in this chapter, we will understand some basic concepts of coordinate geometry. You will understand more about these in the higher classes. This study was initially developed by the French philosopher and mathematician René Descartes. Now moving on, you already know how a number line works, right? It has positive numbers as you move to the right of 0 and negative numbers as you move to the left. Now, take a copy of this number line and rotate it 90 degrees counterclockwise so that the second number line is perpendicular to the first line and intersect at their zeros. Now, this point where both the lines intersect is called the origin. So what we have now is a two-dimensional version of a number line called the two-dimensional plane or the Cartesian plane. In honor of Descartes, the system used for describing the position of a point in a plane is also known as the Cartesian system. Now, the horizontal line is named as x-x and the vertical line is named as y-y. The horizontal line x-x is called the x-axis and the vertical line y-y is called the y-axis. Also, the origin is denoted by O. Since the positive numbers lie on the directions OX and OY, OX is called the positive direction of the x-axis and OY is called the positive direction of the y-axis. Similarly, OX' is called the negative direction of the x-axis and OY' is called the negative direction of the y-axis. So because of these variables x and y, the two-dimensional plane is also called the xy plane. Observe that the two axes divide the plane into four parts. These four parts are called the quadrants. A quadrant means 1/4 part. So, each of these parts is a quadrant. Quadrants are numbered 1, 2, 3 and 4 anti-clockwise from OX. So, the plane consists of the axis and these quadrants. We call the plane the Cartesian plane or the xy plane. The axes are called the coordinate axis. So guys, this was all for today. In the upcoming video, we will learn about the Cartesian plane in detail. Now, let's do a quick recap. To locate the position of an object or a point in a plane, we require two perpendicular lines. One of them is horizontal and the other is vertical. The plane is called the coordinate plane or the Cartesian plane and the lines are called coordinate axes. The horizontal line is called the x-axis and the vertical line is called the y-axis. The point of intersection of the x-axis and the y-axis is called the origin. It is denoted by O. The coordinate axis divide the plane into four parts called quadrants. Quadrants are numbered 1, 2, 3 and 4 anti-clockwise from OX. In the previous video, I gave you a brief introduction about the Cartesian plane. Now, there is actually a lot to learn about this Cartesian plane. So, are you ready? Let's begin. Now, before moving forward, let's revise what we have studied in the previous video. We saw that to locate the position of an object or a point in a plane, we require two perpendicular lines. One of them is horizontal and the other is vertical. The horizontal line is called the x-axis and the vertical line is called the y-axis. The point of intersection of these axes is called the origin. It is denoted by capital O. So, this two-dimensional version of a number line is called the two-dimensional plane or the Cartesian plane. And these lines are called the coordinate axis. Moreover, the coordinate axis divides the plane into four regions called quadrants. Quadrants are numbered 1, 2, 3 and 4 anti-clockwise starting from OX. So we studied till here, right? Now let's move forward. We know that with the one-dimensional number line, we can plot various numbers or points on it. But no matter how many points we plot, they are always on the same number line. But with the Cartesian plane, we can plot points anywhere in this 2D space. I mean to say, we can plot points in the quadrants as well. Moreover, with the one-dimensional number line, we just needed one number to plot a point. But with the two-dimensional Cartesian plane, we actually need two numbers to plot a point. These numbers are called coordinates. Now, there is a special way of writing coordinates. So let's see how coordinates work. Consider this figure where the axes are drawn on a graph paper. So this is how we draw coordinate axis on a graph paper. Now let's take 2 points, say A and B, like this. Let's find the distances of the points A and B from the axis. For this, draw perpendiculars AM on the x-axis and AN on the y-axis. Similarly, draw perpendiculars BR on the x-axis and BS on the y-axis. Now, the perpendicular distance of the point A from the y-axis is 4 units. This distance is measured along the positive direction of the x-axis. Note that here AN is equal to OM. Further, the perpendicular distance of point A from the x-axis is 3 units. This distance is measured along the positive direction of the y-axis. Here again, AM is equal to ON. Now it's your turn. So tell me the distance of the point B from the x-axis. Yes, you are correct. The perpendicular distance of the point B from the x-axis is 2 units. It is measured along the negative direction of the y-axis. Also, OS is equal to RB. In a similar manner, the perpendicular distance of point B from y-axis is 6 units. It is measured along the negative direction of the x-axis. Here again, OR is equal to SB. Now, using these distances, we write the coordinates of the points. For that, we follow 3 conventions. Let's see. In stating the coordinates of a point, the x-coordinate comes first and then the y-coordinate. The 2 numbers are put inside the parenthesis with a comma between them as a separator. These 2 numbers are called coordinates because they are of the same importance or order, and they work together to specify the location of a point. In fact, that's why the Cartesian plane is often referred to as the coordinate plane. Now let's see how we get the x and y coordinates of a point. Let's first discuss the x-coordinate. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis. The coordinate will be positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. Like here, for point A, the x-coordinate is plus 4 because it is along the positive direction of the x-axis. And for B, it is minus 6 because it is along the negative direction of the x-axis. The x-coordinate is also called abscissa. Now, the y-coordinate of a point is its perpendicular distance from x-axis measured along the y-axis. The coordinate will be positive along the positive direction of the y-axis and negative along the negative direction of the y-axis. Like here, for point A, the y-coordinate is plus 3 because it is along the positive direction of the y-axis. And for B, it is minus 2 because it is along the negative direction of the y-axis. The y-coordinate is also called the ordinate. Hence, the coordinates of A are 4 and 3 because I just told you the x-coordinate comes first and then the y-coordinate. So tell me, what are the coordinates of point B? Yes, correct. The coordinates of point B are -6 and -2. Note that the coordinates describe a point in the plane uniquely. Point 3, 4 and 4, 3 are not the same because the point 3, 4 indicates that P is located at a distance of 3 units from the y-axis and 4 units from the x-axis. Whereas the point 4, 3 indicates that Q is located at a distance of 4 units from the y-axis and 3 units from the x-axis. This means that the order of x and y is important in x, y. Therefore, x, y is called an ordered pair. The ordered pair x, y is not equal to y, x if x is not equal to y. Like here, 3, 4 is not equal to 4, 3. Also, x, y is equal to y, x if x is equal to y. For example, 1, 1 is equal to 1, 1 because here both x and y are equal to 1. Now, it's time to have fun by taking simple examples. So, consider this graph which shows 4 points, namely P, Q, R and S. Fill the correct information about these points. Let's start with point P. We know that the abscissa and the ordinate are nothing but the x and y coordinates of a point. So here, we have to find the coordinates of point P. Remember that the x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis. Here we can see that point P is 4 units away from the y-axis. Also, it is along the positive direction of the x-axis. So, the x-coordinate is taken to be positive, that is +4. Further, the y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis. Here we can see that point P is 3 units away from the x-axis. Also, it is along the positive direction of the y-axis. So, the y-coordinate is taken to be positive, that is +3. Hence, the coordinates of point P are 4 and 3. Great. Now let's find the coordinates of point Q. Here we can see that point Q is 3 units away from the y-axis, but it is along the negative direction of the x-axis. So, the x-coordinate is taken to be negative, that is -3. Always remember to check the direction of the axis. Further, point Q is 4 units away from the x-axis. Also, it is along the positive direction of the y-axis. So, the y-coordinate is taken to be positive, that is +4. Hence, the coordinates of point Q are -3 and 4. Now, it's your turn. Pause the video and fill the blanks in options 3rd and 4th. Resume once you are done. Are you done? Great. Now let's check what you have got. From the graph, it is clear that the x-coordinate of point R is -5 and its y-coordinate is -4. Hence, the coordinates of point R are -5 and -4. Lastly, the x-coordinate of point S is 3 and the y-coordinate is -4. Hence, the coordinates of point S are 3 and -4. So guys, I hope you had fun learning about the Cartesian plane. In the upcoming video, we will learn more about the Cartesian plane by solving some examples. Now let's do a quick recap. To locate the position of an object or a point in a plane, we require 2 perpendicular lines. One of them is horizontal and the other is vertical. The horizontal line is called the x-axis and the vertical line is called the y-axis. The point of intersection of these 2 axes is called the origin. It is denoted by capital O. The plane is called the Cartesian or the coordinate plane, and the lines are called the coordinate axes. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis. The coordinate will be positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. The x-coordinate is also called the abscissa. The y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis. The coordinate will be positive along the positive direction of the y-axis and negative along the negative direction of the y-axis. The y-coordinate is also called the ordinate. In stating the coordinates of a point, the x-coordinate comes first and then the y-coordinate. The two numbers are put inside parentheses with a comma between them as a separator. The ordered pair x, y is not equal to y, x if x is not equal to y. Also, x, y is equal to y, x if x is equal to y. Hi guys, welcome to another amazing video of this chapter. Till now, we have studied the Cartesian plane, the coordinate axis and the coordinates of a point on a plane. Now let's move forward and learn how to plot a point on a plane. Let's start with coordinates. We know that the x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis. The coordinate will be positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. The x-coordinate is also called the abscissa. The y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis. The coordinate will be positive along the positive direction of the y-axis and negative along the negative direction of the y-axis. The y-coordinate is also called the ordinate. Let's take this simple example to understand the coordinates better. We have to write the coordinates of the points marked on the axis. Here we can see that to reach the point A from the origin, we have to move 4 units along the positive direction of the x-axis. Therefore, the x-coordinate is +4. And since the point is not moving along the y-axis, the y-coordinate is 0. Hence, the coordinates of point A are 4, 0. Similarly, the coordinates of point B are 0, 3. And why? Because to reach point B from the origin, we have to travel 3 units along the positive direction of the y-axis and 0 units along the x-axis. Therefore, the x-coordinate is 0 and the y-coordinate is +3. Now what about the coordinates of point C? Any guesses? Wait, let me tell you. To reach point C starting from origin, we have to travel 5 units along the negative direction of the x-axis and 0 units along the y-axis. Therefore, the coordinates of point C are -5, 0. Similarly, to reach point D starting from origin, we have to travel 0 units along the x-axis and 4 units along the negative direction of the y-axis. Hence, the coordinates of point D are 0, -4. So what can we conclude from this example? Well, if you observe carefully, you will see that if a point lies on the x-axis, then its y-coordinate is 0. And if a point lies on the y-axis, then its x-coordinate is 0. Interesting, isn't it? So we can conclude that the coordinates of any point lying on the x-axis are of the form x, 0 and the coordinates of any point lying on the y-axis are of the form 0, y. Hey, can you tell me the coordinates of the origin? Well, we measured the coordinates from the origin, right? So, to reach the origin, starting from the origin, how much did we travel along both the axes? 0, right? We actually didn't move. Therefore, the coordinates of the origin are 0, 0. Great. Now consider this plane. What can you say about the signs of the coordinates of a point by looking at the quadrants in which they lie? No idea? Let me tell you. If a point is in the first quadrant, then both the coordinates will be positive because the first quadrant is enclosed by the positive x-axis and the positive y-axis. If a point is in the second quadrant, then the x-coordinate will be negative and the y-coordinate will be positive because the second quadrant is enclosed by the negative x-axis and the positive y-axis. If a point is in the third quadrant, then both x and y coordinates will be negative because the third quadrant is enclosed by the negative x-axis and the negative y-axis. Lastly, if a point is in the fourth quadrant, then the x-coordinate will be positive and the y-coordinate will be negative because the fourth quadrant is enclosed by the positive x-axis and the negative y-axis. Note that the Cartesian system we are studying about is accepted all over the world. The system could also have been, for example, the ordinate first and the abscissa second. However, the whole world sticks to the system to avoid any confusion. Up till now, I have drawn the points for you and asked you to give their coordinates. Now, I will show you how we place points in the plane if we know their coordinates. We call this process plotting the points. Let the coordinates of a point be 3, 4. We want to plot this point in the coordinate plane. We first draw the coordinate axis and choose our units such that 1 centimeter represents 1 unit on both the axes. Before plotting a point, remember that if a coordinate is positive, we will move towards its corresponding positive axis. And if a coordinate is negative, we will move towards its corresponding negative axis. Here, both the coordinates are positive, so we will move towards the positive axis. So, start from the origin and move 3 units in the positive direction of the x-axis, and then move 4 units in the positive direction of the y-axis. That is, move 4 units upwards. Hence, we reach the point 3, 4. We can take one more route. We can first move 4 units in the positive direction of the y-axis and then we can move 3 units in the positive direction of the x-axis. Hence, we reach the point 3, 4. See, by either way, we reach the same point 3, 4. Note that point P lies in the first quadrant since both the coordinates of P are positive. Now let's say we want to plot the point -3, 4. Here, the x-coordinate is negative. So we will move 3 units in the negative direction of the x-axis. And the y-coordinate is positive, right? So we will move 4 units upwards towards the positive y-axis. Hence, we reached the point -3, 4. Note that Q lies in the second quadrant since the x-coordinate is negative and the y-coordinate is positive. Also, if we want to plot the point 3, -4, we first move 3 units towards the positive x-axis and then move 4 units down towards the negative y-axis. And thus, we reach the point 3, -4. Let's plot one more point, say -3, -4. Here, the x-coordinate is negative. So we will move 3 units towards the negative x-axis. And y-coordinate is also negative. So we will move 4 units down towards the negative y-axis. Hence we reach the point -3, -4. Since distance cannot be negative, I must say that I am 3 units away from the x-axis, not -3 units. I moved 3 units but in the negative direction. Negative sign just indicates the direction. So always remember that if negative sign is there, you have to move towards the negative axis. Otherwise, you have to move towards the positive axis. So guys, I hope you had fun learning about the coordinate system. Plotting of points in the Cartesian plane can be compared to some extent with drawing of graphs in different situations such as distance time graph, side perimeter graph. in such situations, we may call the axis d-axis, t-axis, s-axis, p-axis, etc. in the place of x and y-axis. Great. Now let's do a quick recap. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis. The coordinate will be positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. The x-coordinate is also called the abscissa. The y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis. The coordinate will be positive along the positive direction of the y-axis and negative along the negative direction of the y-axis. The y-coordinate is also called the ordinate. The coordinate